Right, so we'll start with 2012 question number 50. Right, so basically this says so this is the integration part. So in the integration part they are saying to show that 25 sine cube x plus cube x dx is equal to 4 over 3. Right now, so these were they asking now. So now what I'm going to do is that now I don't know. So there's no straight away thing to integrate cubes in integration. So what I'm going to do is I'm going to convert it in a way that that I can sort of straight away get the answer. So what is that way? So now because there's a cube, so now I remember that sine 3x is what? 3 sine x minus 4 sine cube x. Right now? So from that you can get sine cube x as what? 3 sine x minus sine 3x over 4. Right now? So in the same way, you can do for cos 3x is equal to what? 4 cos cube x minus 3 cos x. Correct? So now you will get cos cube x as what? Cos 3x plus 3 cos x. Oh. Right now, no problem. No. So then what I'm going to do here is that so then I'm going to substitute here, right? So when I substitute it here, it will be zero to 5 3 sin x minus sin 3x over 4 minus cos 3x plus 3 cos x over 4. Correct now? Right? So now what I can do here is I can take 1 over 4 out. Will be 3 sin x sin 3x minus cos 3x minus 3 cos 6. So write this down for the moment. So right, so you came up to here. Right, so now from here, you have to integrate. So now when you integrate this 1 over 4, so 3 sin x will be what? 3 sin x will be minus 3 cos x minus 3 sin x will be minus cos 3x over 3. This will be sin 3x over 3. This will be 3 sin x. Right now? Correct? So then so then you just need to apply this phi and 0. So now you know that so what is phi? Phi is basically what? 180, right? So now it's basically here. So if you take if you substitute phi here, it will be 3 phi. No? That is basically again up to here 2 phi 3 phi. Correct, no? So basically so yeah, so let's say so let's substitute and see 1/4 minus 3 cos phi will be plus cos 3 phi over 3 minus sin 3 phi over 3 minus sin phi minus cos minus 3 cos 0 plus cos 0 minus sin 0 minus 3 sin 0. Correct, no? So now what is sin 0? Sin 0 is 0. So now this is basically 0. This is basically 0. So what is sin phi? So now all S T C. Right? So now sin phi is also 0. Right? So sin 3 phi is also 0. So 0. Right. So now what is cos 0? Cos 0 is 1. Right, no? This is 1. So this is 1. So what is cos phi now? Cos phi is it's 1, but it's not positive 1. It's negative 1. Right, no? This is negative 1. So cos 3 phi is the same. Is also negative 1. So now you will get 1/4 minus 3 into minus 1 minus 1/3, these are 0, minus 3 into 1 plus 1/3. Correct, no? Then basically then what do you get? This is positive 3. Positive 3 minus 1/3 is what? So let's see, this is positive 3 minus 1/3. This is minus 3 minus 3 into minus is positive 3. So 8 times 6 is 18, 18 minus 2 is 16, so 16, 4 times 3. 4. So that's what we need to prove. Correct? Right, so let's go to part B then. Right, so part B says for us to using integration by parts or otherwise. So basically we will use by parts. Okay. So V, it says what? X3 tan inverse X. Right. So now if I remind you what y part C. This is basically integration by part, right? So what do you call? So for us to find what is u, there is a small norm. It's called I lane. So so whichever comes first is u, right? So here this is inverse. So this is inverse. So this will be u. Okay. So now let's see. So tan inverse x. When you need this part, no? So what I'm going to do is I'm going to what do you call? So for me to get the b part, I need to integrate this. That means x over 4 dx. Right. So now this is v. This is u. This part is v. Correct? So if you differentiate this, you will get this one. So the equation hasn't changed. Right? So how to do that is that you need to integrate. Right? And to get this b. Right? So what happens is, so what is u? This is uv, yeah? So that means tan inverse x4 over 4 minus what is v now? x4 over 4. So differentiation of u. So what is differentiation of tan inverse x? That is 1 over 1 plus x square. Correct, no? So that is, you will get 1 plus x square dx. Correct? So now here what will happen is that you can take, so now these are all okay. I'm going to take 1 over 4 out. Then x4 1 plus x square dx. Right? So I need to simplify this now. I'll take this as I'll take this as I. I can take this as I1. Correct? So I need to somehow simplify this now. So for this only you can do it in two ways. You can use a substitution or the normal way. So let's do the normal way. So first of all, write it down. So now we need to get an answer for I1. So now let's see what we can do. So basically, I1 is this one, correct? So, in order for me to sort of simplify this, I am going to write this in a form like this. So now that means I can write this as 1 plus x squared, that is x to the power 4 will come, but then when there are additional terms, that is not there. 2x squared minus 1. Correct, no? No problem there. Then what happens is that you can divide. Correct? Right? So what I am going to do here is that I am going to add another one. I am going to minus another one. And why am I doing that? So that so now here 2x square plus 2 is basically a part of this. Right? So what I am going to do here is this, no? Correct? So now all this stuff I know, so I can get the answer easily. So what is that? Oh, I know that this part is what? Now this, if I integrate, it will be what? X. It will be x plus 3 over 3 minus 2 will become minus 2x, and this is basically tan inverse. Correct, no? Right? So you will get this. So now you basically simplify this form. So you simplified and got this answer. Correct? Right? So now you just need to add this to the original one, because what is the original one? I was equal to tan inverse x4 minus I1 over 4, right? So you have this I1 here, that is tan inverse x minus 1 over 4. So you always put a C. You always put a C, and you have to say C is an arbitrary constant. Right, so that's basically it. Right, so now if you use substitutions, so basically all the previous steps are equal. I'm just using substitution for I1. Okay, so the substitution that I'm using is that I'm using x equals tan theta, right? So if I differentiate this will become dx over d theta, which is sec square theta. Correct, no? Right? So then dx will become sec square theta d theta, or basically 1 plus tan square theta dt. Correct, no? So now I'm going to substitute. So x4 will be what? Tan 4 theta. This will be 1 plus tan square theta. dx will be 1 plus tan square theta dt. So we have this one. Right? So then you will be stuck with this, no? Right? So now what do we do? So now what is this? It's another tan square theta, which is 1 minus 6 square theta. So we have to think of a substitution here. Right? So write this down. So this will be what? What is sec square theta? 1 plus tan square theta. So tan square theta will be 6 square theta minus 1. So there's a small error there. Okay, so now let's use another substitution. Now you get here. So let's use another substitution called u equals tan theta. Right? That means du over d theta is what? 6 square theta. Right? So now if I evaluate this will be u square sec theta d theta is going to be du. Correct? Minus this will be tan square theta du. Correct? So tan square theta is what? Square theta du d theta, right? Right. So basically, this of course you can get easier. That is u3 over 3. Here, this you can rewrite it as sec square theta minus 1. Correct? Sec square theta minus 1. D theta. Correct? Right now? So now you get here, then what? So now so if I come back here, will get u3 over 3 minus sec square theta d theta minus minus will be plus d. Correct now? Right? So now sec square theta d theta is what? This is going to be du. So if you integrate d theta, it's going to be theta. So you will get, so basically you will get u3 over 3 minus u plus theta. So this is, what is u3? u3 is tan cube 3 over 3 minus tan theta. What is theta? So what was theta? It was tan theta, correct? So basically tan inverse x, right? Or you can keep in terms of theta, right? So basically now, so now we know what's theta. So then you can get the answer, right? So that's a bit of a very complicated way. So the previous way is much more easier, right? Right. So considering part C. So part C says using partial fractions to find the integration. So let's use partial fractions and see. Now right, so we need to integrate this and use the partial fraction. So I'll first of all find the partial fractions. This is basically x minus 2 a x minus 2 square plus x square plus 1. You know, I can find this straight away. You know that method where you close this, so now it is x equals 2, you can close this now. You will get 2 times into 2 square minus 3 into 2 square plus 1. Right? This thing where you close 1 up and get the answer. Right? So here this basically 8 minus 3 is 5, this is also 5, so this is going to be 1. So this part is going to be 1. That means you can simplify this as this one. Correct? Right now? So then you have to basically find A, B, C now. So I'm going to multiply the whole thing. So A x minus 2 x squared plus 1 x squared plus 1 plus bx plus c x minus 2 squared. Right? Right, so now basically we need to find the coefficients. So A, B, C. Right? So what I'm going to do here is I'm going to take the I'm going to compare coefficients of x cube, which is nothing here, 0. Here it's going to be A times A and B, no, so here this will be x squared minus 4x plus 4. So b will have a x cube and a will also have x cube. That means it will be a plus b. Correct? So here you will get a equals minus b. Then we will compare the constant, or basically when x equals 0. That means minus 3. So if you put x equals 0, this is going to be minus 2 into 1 is going to be minus 2a, right? Minus 2a plus 1. Then if you put minus x equals 0, this is going to be 0. C plus 4c. Correct? So now here you will get, if you put 1 here, it will be minus 4 equals minus 2a plus 4c. That means minus a plus 2c is equal to minus 2. Right, so here this is the second one. So you can get something as a equals 2c plus 2. Correct, no? Then, so then I'm going to compare the x squared part. So it's going to be 2 here. So if you take x squared, it will be minus 2a plus 1, that is this, and you will get minus 4b and plus c. Correct, no? Then, so then I'm going to substitute a equals what do you call so I'm going to substitute for b, I'm going to use a. So minus b is basically a, no? So this is going to be 4a, right? So this is going to be 2 equals minus 2a plus 1 plus 4a plus c. Right? So this will be 2a, right? So this will be 2a, this will be c. So you will get a equation as 2a plus c, 2a plus c plus 1 equal to 2. Right? Correct, no? So here I am going to substitute for a. So that is going to be 2 times 2c plus 2 plus c plus 1 is equal to 2. Then you will get c as minus 305. Okay? So you get minus 305. Then you will get a as 1. So a is basically 2c plus 2. No? That means 2 times minus 305 plus 2. Correct? So that is basically you will get, so this is going to be minus 6/5 plus 2, that is going to be 4/5. Okay? So because it's 4/5, b is going to be what? B is basically minus 6, so b is going to be minus 4/5. Right? So basically we have found all the coefficients that we need. Right? So now let's substitute this stuff. we found uh, A is going to be 4, 5. B is going to be minus 4, 5. C is going to be minus 3. Okay? So now what you need to do is what? You need to basically integrate this. No? So if you integrate, what will happen is that you can take 4, 5 out. Then here this will become 1 over x over 2 dx plus this will become x minus 2 minus 2 dx minus 4x plus 3 x square plus 1 dx. Correct, no? Right? So now basically we, so for all of these we know the answer straight away. So I'm not going to bother about them, but I'm going to bother about this I1. So I'll put this as I1. So I1 is going to be 4x plus 3 x square plus 1 dx. So here I am going to put, so if I differentiate this, I will get 2x. Correct. So I am going to write this as 2 times 2x. Right? X square plus 1 plus 3 x square plus 1. Right now? So now basically what I do here is I am going to take 2 here, 2x x square plus 1 dx plus 3 x square plus 1 dx. So this is going to be 2 times, this is going to be ln x square plus 1. This is going to be 3 tan inverse x. Right now? So I'm going to I know I1. So if this is I, so I can write I as 1. So if you differentiate, so if you integrate this is going to be ln x minus 2, right? So I can write this as 4, 5 ln x minus 2 plus this is going to be what? You add 1 up, so that means x minus 2 minus 2 plus 1 minus 2 plus 1, right? So this is what? Minus 2 plus 1 is minus 1. This is x minus 2 minus 1 is minus 1. So you can actually write this straight away as minus 1 over x minus 2. Right? You all know that? Correct? Plus, so the I part, so the I1 part, that means 1 over 5 times this. Plus C. Correct? So in the, what you call the usual notation, you put C is an arbitrary constant. Right, so you have to write, you have to write now, C is an arbitrary constant. So you write it. Right, so from that, this part is over.